So this video is an attempt at a basic review of right-angle trigonometry. Some of the things we're going to be looking at: how cool is trigonometry, reading right-angle triangles and ratios, finding a side, finding an angle, and a couple of bonus sample questions for you to try. Okay, trigonometry, how cool is it? Well, first off, let's have a look at a right-angle triangle. So right-angle trigonometry is all about relationships. Wonderful. So in this right-angle triangle, these two angles have to add up to 90 degrees at all times. And if I change the length of two of the sides, I am changing the angles along with it. Now you might think, yeah, sure, that's pretty obvious. So right-angle trigonometry came about because people observed that when you had a specific angle, now I'm going to just stop this randomly at, hopefully I can get it at 32 degrees. Oh, close enough. We'll call that 32 degrees. What I'm going to do is I'm going to take a photo of that 32 degrees using the desktop tools. Okay, so taking a photo, right. Sorry about that. Okay, to the current page. So when we look at this triangle, I've just taken a photo of this angle here being 32 degrees. And when this is 32 degrees here, and I choose two side lengths, that side there and this side here, they will always be in a very particular ratio. So in this case, this is the hypotenuse and the adjacent, so that's the cosine function, or cos. Don't worry, I'm coming back to that. You don't need to worry about that at the moment. But cos from 32 degrees, being very dodgy here, cos from 32 degrees is always going to have a ratio of 5.92 on 6.98. And that is the adjacent side on the hypotenuse. But when we look at this thing here, this fraction could be expressed as a decimal. And if I grab my handy dandy calculator and go 5.92, how about I turn it on first? 5.92 on 6.98, we get this 0.848. 0.848, and it actually goes on and on and on and on and on. The point I'm trying to make here is that people have mapped all of these relationships from particular angles. And they mapped these relationships because they were very important for use in industry and travel and, well, you name it. And they're also just mathematically fascinating things. So mapping means particular ratios, that is two sides compared to each other from a particular angle. And in the olden days, they published these whole books that were full of these ratios, sine, cos and tan, and three bonus ones which we don't need to know, but we will discuss briefly. And all the way down here, these are all the sizes of the ratios, these fractions turned into decimals from different angles. And so that's what we're going to make sure we can do as well. Luckily, we live in an age where our calculators have these tables stored inside of them, and some of our calculators actually work out the ratios for us as we go. Without further ado, let's get stuck in. We're going to start with the main, one of the central skills, and that's reading triangles. I want to make sure we understand how to quickly and efficiently read a right-angle triangle. And so what I mean by that is, we are imagining we're given an angle down here, and we've got to work out, when I'm sitting down here, what are the three sides? I like to imagine that I'm really, really tiny and I'm sitting at this point here. And so the hypotenuse is always the longest side. It's always the side that is not touching the right angle at all. So then from down here, This one over here, the one furthest away, is the opposite side, and the leftover one is the adjacent. And personally, that's how I always do it. I always identify, let's go over to this other triangle, I always identify the hypotenuse first, then the one furthest away, the one not touching my angle at all, that must be the opposite, and then the leftover one is the adjacent. Now notice I have to sit myself down in the corner first, then work out which one's the hypotenuse, which one's the opposite, and which one is the adjacent. You see, we need two of these sides to answer any trig ratio question, because we make pairs of sides to make these ratios. Let's have a look at the possible pairs of sides we can make. So back to here, identifying that this is the hypotenuse, always the longest side is the hypotenuse. This one is the furthest away from where we're sitting down here, so that must be the opposite. And the leftover one must be the adjacent. I could, if I wanted to, combine the opposite with the hypotenuse. That's one combination of a pair of sides. I could combine the adjacent with the hypotenuse, and I could combine the opposite with the adjacent. There are three possible ratios, and they're the three that we want to know about. There are actually another three, and these are, if you look at this, if this is opposite on hypotenuse, this is just the reverse of that. And if you're going on to methods or specialists, you will get to know these, but we don't need to know them yet. We only want to know these three. And this one is called, this one is called sine, and that's actually S-I-N-E, but we abbreviate it in trigonometry. This is cosine, and this is tangent. They're just fancy pants names for saying from some angle I want the opposite on the hypotenuse. From some angle I want the adjacent on the hypotenuse, or I want the opposite on the adjacent. Personally, I think the hardest thing about trigonometry is just remembering SOHCAHTOA. That sine is the opposite on the hypotenuse, cos is the adjacent on the hypotenuse, and tan is the opposite on the adjacent. They always follow the same order. This one will always be on this one. Same again, top on bottom, top on bottom. If you can remember, some old hippies can't always hide their old age or some other mnemonic, some memory device to remember SOHCAHTOA. Everything else just becomes a process. And the process is this. Read your triangle, choose your ratio, write your ratio out carefully, rearrange it, calculate it, and then check your answer to make sure, are you after an angle or a length? So let's try some examples, and I'm just going to show you that no matter what kind of question it is, you always start the same way. So just to begin with, we're just going to look at this part here, reading a triangle, choosing a ratio, and writing it out carefully. And then we'll go on from there. So here's my right angle triangle. You may want to pause and practice reading the triangle, choosing the ratio, and writing it out. Alright, I'm going to do it now. So reading the triangle from this angle down here, I've got the, let's just check. There's the hypotenuse. This must be the opposite, and this must be the adjacent. So which two sides am I working with this time? I'm working with the opposite and the adjacent. So just to remind myself, SOHCAHTOA. So which one have I got? Which one has opposite and adjacent? Opposite and adjacent is TOA or tan. So I must be working with tan from some angle equals opposite on adjacent. Pardon my terrible finger writing. That says opposite, everyone can tell. Yeah, opposite on adjacent. Okay, so I'm going to put in the information I've got. This time I've got an angle to put in, and I've got the adjacent to put in. I'm going to rewrite it out. Tan, hopefully a bit neater, tan from 70 degrees equals opposite, which is x, on the adjacent, which is 26. Now we're going to go further with this in a moment, but just want to clarify, all kinds of questions start the same way. So I'm going to go to the next one. Here we have a new triangle. Again, I'd like you to pause it and see if you can get as far as I did in the last question. That is, read the triangle, choose the ratio, write out the ratio, and fill in the information that you know. Alright, here goes. So if I'm here, here's my hypotenuse, the longest side, here's my opposite, and the leftover one must be the adjacent, but I'm not going to bother with that because I can see the two sides I'm working with are the opposite and the hypotenuse. I check SOHCAHTOA again, SOHCAHTOA. And which one has opposite and hypotenuse? Only this one does, so it must be sine. So I write sine from some angle. Oh, that's terrible. Equals opposite on hypotenuse. Okay, and now I'm just going to fill in the information I've got. I've got an angle and I've got the opposite side. So I go sine from 52 degrees equals opposite 6.3 on hypotenuse, which I don't know, so I put in the pronumeral p. Okay, last one in our examples. Again, we're just practicing reading the triangle, choosing the ratio, writing out the ratio. Okay, so reading the triangle from this angle here. Here's the hypotenuse. This one over here must be the opposite, and leftover one must be the adjacent. Okay, with that in mind, I again have the opposite and the hypotenuse. Notice how it doesn't matter which ratio we're working with. I'm not trying necessarily to show you every ratio. The process is the same whether it's sine, cos or tan. So this time we have the opposite and the hypotenuse. Let's just check SOHCAHTOA again. So that's no. SOHCAHTOA. Okay, so which one has opposite and hypotenuse? That one must be sine. So sine from some angle equals opposite on hypotenuse. So now I put in my information, sine, and you'll notice this time I don't have an angle. So I just leave it as sine theta equals opposite was 23 and hypotenuse was 32. Now some people like to skip out this first step here. Some people like to skip it out and go straight to this part here. Can I suggest when you're just starting out or you're just reminding yourself of this process, writing out the ratio gives you a former, gives you a little tool that then you can check which side has gone where. So it's a good way to start out. But how do you finish these? Alright, so let's go back to this one. Notice the x, the unknown variable in this first one, is up here. And we are finding a side. That's the unknown variable. So in this case, all we need to do is rearrange this equation to get the pronumeral by itself. Now you might want to grab your calculator because this thing here, when you've got an angle and you've got a ratio in front of it, a sine, cos or tan in front of it, this is actually just a number in disguise. You might want to check that by pressing tan 70 on your calculator and you'll find it's just a number. So tan 70 equals, and it's the number 2.7. We don't need to find that yet. I'm just letting you know so that when I do this next bit you're not terribly confused, because all I do to get the x by itself is multiply both sides by 26. Because this is just like any other normal equation. We've got one unknown, and that's this thing up here, this x. This is just a 26, so I multiply both sides by 26, and I've got 26 lots of, tan 70. And now, literally, all I do is grab my calculator and write 26 lots of tan 70. And hopefully you get the answer 71.43. So x is worth 71.43. And it goes on and on, so I'll have to put 2dp. And probably have to write meters, because remember, we have to check. It is a length, so I say how long it is. I want to point out one thing about this kind of question. The pronumeral was on top. The pronumeral was on top. So when it came to rearranging, all I did was multiply. Oopsies. I multiplied when the pronumeral was on top. Anyway, moving right along, let's look to the next one. This one here, again, we're finding a side, but you'll notice this time, where is the pronumeral? It's underneath. Now, this one, some people find a little bit tricky. Well, okay, so I will explain why this works in another video, but just for now, you can swap their positions. See that P there? And that sine 52, we just swap their positions. P equals 6.3 divided by sine 52, and sine 52 is just a number. Your calculator knows what number that is, you don't have to. Sine 52, and we just calculate. So chuck that in your calculator, 6.3 divided by sine 52 degrees equals 7.99. So P equals 7.99. And yes, it keeps going. So this would be millimeters, and we'll say 2dp again. 2 decimal places is standard if they don't tell you how accurate to measure it. But we could keep going. You can do it to 7 decimal places or 14 if you've got a powerful enough computer. Okay, so again, the point here is the pronumeral is underneath this time. There it is there. That pronumeral was underneath. Dearie me. So what did we have to do? We had to swap their positions. We had to swap the ratio, in this case sine, and the pronumeral. So the pronumeral went to there and the ratio went underneath. So there's only 2 types of finding a side question, where the pronumeral's on top and you have to multiply to get the pronumeral by itself, or the pronumeral is underneath and you've got to swap their positions. There's only 2 types of finding a side question. They could be sine, cos or tan, but the pronumeral will be on the top or underneath. Now lastly, finding an angle. And in this case, this is a very strange relationship going on here. These are like Siamese twins or conjoined twins, I guess we say these days. So we need to split these up, and we have to do it using a very special technique. And it's this, sine, and he's missing his brother or sister. Oh no, he's minus 1. Can you see that? That dot was unnecessary. Sine to the negative 1. See that negative 1 up there? And if you look on your calculator and you find sine on your calculator, you'll notice above it, it has sine to the negative 1. Well, if you press shift sine, you'll get sine to the negative 1, and it will open a bracket. And I don't think you'll be surprised. What goes in here is 23 on 32, or whatever your ratio was. Out pops an answer. Now, let's try this. Shift sine 23 on 32. And we get this 45.95. That's not our answer. It's an answer, but it's not our answer. Why? Well, this is an angle. We're trying to find an angle. That's what I meant by you must check your answer. We don't want 45.95. We want 45 degrees. And then whatever 0.95 is, as what's known as minutes. Just like time has hours, minutes, and seconds, measuring angles has degrees, minutes, and seconds. So I'd like you on your calculator to find the button that looks like this. It's the most important button when finding angles. Degrees, minutes, seconds button. It's up the top, and it's, yeah, you'll find it. It's in the kind of middle up the top, not in the middle row. Sorry, in the second column, third from the top. Yeah, okay. So now that you've got your what looks like your answer, press that button and it will change it from a decimal. This is a decimal equivalent. Press the degrees, minutes, seconds button and we'll change it to 45 degrees, 57 minutes. And in another video, I will show you how we can round to the nearest minute or to the nearest degree. And this, of course, was finding an angle. All right, so just to review, we read the triangle, we chose the ratio, we wrote it out carefully, we rearranged, we calculated, and we checked our answer. That is the entire process for most right-angle trig questions. I did promise I will put up some example ones, so here's one here. You might want to pause it, and then try it yourself. Okay, now I'm just going to race through it. Let's see how we go. So, reading the triangle, there's the hypotenuse, the opposite, and the adjacent. Okay, so I've got the hypotenuse and the adjacent. So which ratio is that? It is cos, because cos is the only one that has A and H. So cos from some angle equals adjacent on hypotenuse. So I put in what I know. I know that I don't know the angle, but I do know the adjacent is 17.4. I know the hypotenuse is 24.8. I rearrange. Theta equals cos to the negative 1. And that angle goes in there. I'm not writing it out again. I grab my calculator, shift cos 17.4 on 24.8. There's my decimal answer, but I press degrees, minutes, seconds, and theta is 45 degrees. And this is actually 27 minutes. Sorry, I will have to explain this. You'll notice on your calculator, if you've tried this, it says 45 degrees, 26 minutes, 36 seconds. Now have a look at those 36 seconds and think about a minute. If you want to find the halfway mark for a minute, then that would be 30 seconds. We've got more than 30 seconds, so we're past halfway to the next minute. So I have to round up. My 26 minutes becomes 27 minutes because there were enough seconds to bring me up to the next nearest minute. I hope that made sense. Okay, next one. I'll try that one. And here I go. Okay. Remember, you're allowed to pause it, you're allowed to try it, otherwise I'm just going to go for it. Okay, so I'm sitting here, so there's my hypotenuse, I'm reading the triangle, there's my opposite, and the adjacent is the leftover one, so that's the opposite, and the adjacent is the leftover one. Okay, so, which two sides do I have? I've got the opposite side and the hypotenuse, and so that's sine again. The sine from some angle is opposite on hypotenuse. So then to put in what I know sine, I've given an angle of 67 degrees. Opposite is my unknown, and the hypotenuse is 2.45. Okay, so the pronumeral is on top. So what do I do when the pronumeral is on top? I multiply. So 2.45 times, you don't have to write the times. If you write it just next to the sine 67, the times is implied, equals A, and I calculate 2.45 times sine 67 equals 2.255. So A equals 2.255 meters. Yeah, okay, last one. Oh dear. Go for it. Okay, here I go. So from here, there's my hypotenuse, there's my opposite, there's my adjacent. So this time I'm working with the opposite and the adjacent. So I look at my SOHCAHTOA, and which one is the only one with opposite and adjacent? That's a terrible A. Opposite and adjacent, tan. So tan theta, tan from some angle equals opposite on adjacent. So what do I have here? Tan 71, tan 71, 71 equals, opposite is 814, and the adjacent is the unknown. And now we can see this time the unknown, the pronumeral, is underneath. So I need to swap the position of the tan and the pronumeral. So F equals 814, 814 on tan 71. And I just calculate. So 814 divided by tan 71. And we get 280.28. And in this case we were dealing with millimeters. Okay, so there's plenty of exercises in the textbook and on MathSpace, which I will set. Okay, I hope that was helpful. See ya.